Hi, my name is Casey Rosenthal. Those of you who know me from Ruby games know that I like really interactive environments. It's kind of hard to do in this kind of form. But I have 4 quick questions that'll help me customize some of my examples. So by show of hands, how many of you are here in New York? Like work here permanently, okay. Okay, and how many of you have a how many of you have a bachelor's degree in computer science? How many of you hold a master's in computer science? How many of you have taken a class in AI? Oh, interesting. A lot more of you. Okay, cool. Okay. So me, Casey Rosenthal, right now I work full-time for NASA through Caltech and JPL. So for some of us, Ruby is rocket science. Take that, hash rocket. Like many of you, I'm sure, I'm also CTO of a startup here in New York called Explorist. I'm not going to talk about NASA. Explorist is a site for an application for scientists. I'm not going to talk about that either. I'm going to talk about a library that I wrote called HysteriaEngine. And the subtitle to my talk is Ruby Does Violence in the Name of Science. Trust me, that's what it says. So let me set the scene for you for my presentation. Picture Copenhagen, wonderful city. Last year in August, I was in a room, a computer lab full of computer scientists, and I did what I had to do, what I was brought there to do. I opened fire. I let loose a barrage of bullets and stabbed, shot, exploded my way to the ultimate glory. Okay, technically I only got 4th place in the 2K bot prize. What's the 2K bot prize? I'm so glad you asked. Let me show you. Here is actual footage from the 2K bot prize. And it's kind of hard to see, so I'll narrate for you. Pew pew. Let me go to another one. Let's see, that's really dark too. Maybe this one's a little bit brighter. Yeah. Okay, so basically what you're looking at is Unreal Tournament 2004. Guys jumping around, shooting each other. 2K Bot Prize is a Turing test that takes place in a video game. Turing test is, generally speaking, is basically a test to see if you can write a program to convince a human being that they're actually communicating with another human being. So the rules for the 2K Bot Prize, it's an international competition. Basically, in this computer science lab, you have a bunch of judges, human judges, who are playing. And there are also a lot of characters who are being played by bots. And you can play normal, but the human judges also have a link gun. And with regular fire, they can indicate that they think the person they're shooting is human, or a bot. And with alternate fire, they can indicate that they think that they're human. So if they're right, that character dies and they get a lot of points. If they're wrong, they die and they lose a lot of points. So they have an incentive to correctly identify characters and non-characters. And the players, the bots, the people who are competing on my side of things, we basically have a threshold of 80% of the judges have to judge us as human in order to win. Nobody's won yet. I'll be competing again this year. Yeah, so that's the stage. That is the 2K Bot Prize. So my presentation, I'm gonna go through 4 subjects. I'm gonna take a slight detour through science in general, then the theory that I use to approach the competition, and then the algorithm that I created to play this game, and then the results. So science. What got me started thinking along the lines that I'm going to go into here was a quote from a friend of mine. many years ago, he said, "I wouldn't touch a gem or plugin if it doesn't have tests." And of course, I'm sure this is true of all of us now. We're all doing TDD all the time. I know this. But at the time, it was like, it made sense, but it made intuitive sense, but it didn't necessarily make logical sense. I couldn't say why that was the case, because people can write crappy tests, and just because there's tests doesn't mean that the code is good, and so on. But it kind of clicked for me that there's kind of a parallel between test writing and principles of Western science, the scientific method. Which brings me to my next quote. If a subject has the word science in it, then it probably isn't. You can think of other subjects with the word science in them. I won't try not to pick on any of the other ones. But I'm actually reminded of this daily at NASA by my peers, because they're astrophysics, they're real scientists, and I'm just a software engineer. I'm not a real scientist. But our field is very young, and hopefully it is a science. But I'm going to kind of argue that we're still kind of determining whether or not that's the case. So semantically, what do we mean by science? Well, I don't want to upset anybody, so I'm not going to talk about magnets. But there's basically, I'll pull from Ayer and Popper and some philosophers of science, but I won't get deep into that. I just want to touch on 3 points: verification, peer review, and validation, which is closely linked to this concept of falsifiability. So verification. That means that you can dig into your model, whatever you're studying, tease apart things that are working, and make sure that it is doing what you think it's doing. So it's easier to illustrate this with an example of what's not verifiable to all of us. Anyone here work for Microsoft? Cool. To all of us, Windows cannot be verified. So I am writing, this presentation on Word, not really, but if I was, and I click Save, I get the blue screen of death. And so Windows, a Microsoft rep might say to me, yes, we have this function that, when you're saving something important, it will give you the blue screen of death. I have to take his word for it. For all I know, it could really have been trying to display a rainbow and just got stuck on the first color and showed that, right? Anything that is closed source to you is not science for you. Okay? So, because compilation is a form of obfuscation. We don't really deal with that too much in Ruby and JavaScript because, compilation. But that's just something to keep in mind. And I'll come back to. So peer review. Most people think peer review is great because you can't think of everything yourself, so the more eyeballs, the more ideas you get. That is important. However, I think in science generally, peer review is even more important because it forms consensus. So we're used to consensus in the Rails world anyway, and I'm sure a lot of you are Rails developers. It's a conventions-based framework. Not all the conventions are the best. Certainly they aren't all democratic. Some are forced. But we understand that there's consensus, and it helps build a community, and it's something that's an integral part of the Ruby stage. GitHub, I think, is actually is arguably the most important tool to computer scientists right now because of what it's doing for peer review and source code sharing. And the third one is validation. So falsifiability is the more sturdy science term. And that basically says that you can never say that this is true. You can never assert that. What you can do is say that all of these other things that are alternative explanations, you can say those I can prove are false. And the more of those you prove are false, then the more likely you think that this actually is true. So the other way around validation is saying that whatever model you're looking at actually produces the results that you want it to. And going back to Rails, we kind of have a correlation here between verification as like unit tests making sure that modules do what they should, what classes do what they should, and validation would be more like integration tests, that the whole application kind of gives us a truthy result. So I'll be coming back to these 3 points, but these really form the basis of how I look at going about designing an algorithm, a library like what I'm showing you. And I hope some of you who haven't considered it before also have the takeaway that, the people in this room, the Ruby community in particular, we embrace these, or at least it's my experience that we have embraced these as a community before other programming communities have. And in an early stage in a subject like computer science, that means we have a lot of impact, a lot of responsibility, right? Great power comes great responsibility. So, maybe someday we'll take the word science out of it and, computology or something. I don't know. I don't think that'll stick. So, okay, so we want to build a bot to win this test. 2K bot prize plan. First, let's look at the tools and then the requirements we want for our algorithm. Tools. Here's how Unreal Tournament usually works. Up here, the red boxes all say UT 2004 client, for those of you who are having trouble reading that. So we have an Unreal Tournament server, and that can be anywhere on the internet. And up here, we have the video game, people who are actually running the client, right? They all connect to the server. It's a master server. They don't talk to each other. And traffic goes down the server. The server is responsible for all of the timing conflicts and resolutions and things like that. It has the final say. There's only one master server. So our tools, we have a program already written called GameBot, which can connect to the Unreal Tournament server as if it were a client. So it connects over TCP/IP, and it basically speaks the same language. It abstracts it a little bit into, instead of coordinates, it has words for like move. On top of that, very helpful, we have another app library called Pogamut. I don't know where the name comes from. It's kind of weird. And that adds another layer of abstraction that says, instead of just the coordinates of something moving, it can kind of say where it's going. And it also does pathfinding for us, which is great because if I'm writing a bot, I basically want to say, go from here to the door. Pathfinding's a solved problem, so I don't want to rewrite the logic of going down there and then going off at an angle to get to the door. So it has convenience methods classes like that, which is great. And it takes care of events coming in, like you've been hit, and events going out, like fire, press your fire button. So on top of that is the actual bot. And Pogamut actually comes with an example bot. They call it the hunter bot, which is great. So we've got these great tools. Bad news is it's in Java. So this is NetBeans, which is not fun for Vimmers. But hey, we've got JRuby. So what I did was I wrote my classes in Ruby and then just used JRuby to compile them into Pogamut. So it wasn't, we could sidestep that easily. So Pogamut, it's basically, in the bot, it basically gives you an event loop where these messages come in, state changes and environment changes. Events are changes in environment or state. And then it emits actions, which the bot then actually carries out on screen. So those are the tools. Now the requirements. Requirements for our algorithm, because we want to win this thing. Okay, first of all, it has to operate asynchronously, right? That's kind of, maybe that's not obvious. Well, no, it wasn't obvious when it started. So we don't want a bot to run and then turn and then shoot, because he's going to look robotic and get slaughtered also. He has to be able to run and look and shoot at the same time. Fortunately, the way Pogamut is written, doing something asynchronous isn't difficult. We just have to keep that in mind when we emit actions, that they have to happen asynchronously. Here's a hypothesis. This is one that follows me around in AI. To recognize actions as human behavior, a series of actions must be both unpredictable and feasible. Let me illustrate that. Let me pick on somebody. Okay, so you're going to love it. So Harris, say I see Harris sit down and open up Vim, right? I would say that's unpredictable because he loves TextMate and hates things that are cool. But but then say I see him edit a file and save it and close Vim without any help or any instruction. Well, that's just not feasible because Vim is not intuitive. So there's a whole, that's kind of a whole other subject on behavioral psychology, but 2 key points: unpredictable yet feasible behavior. That's what we want. Another question is fight or flight. This is kind of similar to the asynchronous question, or issue. But say I have my bot, whatever rule system I'm using. He sees another character, and he has to make a decision. Does he go attack, or does he flee? So what we want is, maybe he has reasons to do both. But in this case, attacking wins out, and so he goes and does that. But that doesn't mean that his reasons for fleeing leave. So maybe you can imagine them as like pressures. And first, the pressure to fight wins out, but then his health goes down or something, and so that pressure decreases. And then the pressure to flee is greater. So his behavior turns on a dime. He goes from attacking to running away. But this like motivation behind it does not change on a dime. Those move in a different way. So to answer the question, fight or flight, we kind of want both. And because of that, we need something that's stateful. So it has to remember, the application has to keep track of what these motivations were previously. So now those are the requirements of what we want the bot to do. We need a theory, a framework to implement this in. I looked around a lot, didn't find good ones. So a lot of the other competing algorithms, they use neural networks and evolved genetic algorithms and a lot of rules-based algorithms to implement their bots. For various reasons, those won't satisfy our requirements, those approaches. So I looked around in other sciences, and in behavioral psychology, I came across the Big Five. The Big Five is a personality profiling theory in psychology. And it basically says that it's sufficient to describe a human's personality by breaking it down to 5 factors. These are the 5 factors. Extroversion is how much you want to be with other people, roughly. Agreeableness is how likely you are to be influenced by other people's behavior. Conscientiousness is how determined you are to finish a job. Neuroticism is how well you react to stress or are influenced by stress. And openness you can think of as imagination. So what's great about this theory, there's a lot of things that are great about this theory, but they have, the behavioral psychologists, they have good correspondence between testing people for extroversion and then how they actually react in a given situation. Well, for all of the factors. To take extroversion as an example, they say, oh, these people are highly extroverted, and I'm making this up, but you put them in a crowded room and they all introduce themselves to at least 3 new people. So there's a good correlation. What they can't say is that there's causation. They can't say that because we can't crack a human brain open and find extroversion yet. Maybe somebody's trying, I don't know. But what we want to do is that's exactly what we want to do. We want to generate behavior. We want to imply causation. So, heck, that's what we'll do. We will just assume causation. So we'll start with this very simple model of a bot. There's 5 numbers. I'm just picking from -1 to 1. These are floats. And those can represent the bot's personality in this big 5 model. So I have 0.7, 0.1, 0.2, negative 0.1, 0.2. So we kind of average, except he's high in the extroversion factor with close to 1. So that's the theory. It seems like it would work. How do we turn this into an algorithm? Let's look at the algorithm. Okay, so we start with that bot. Very simple personality. An event comes in. An event coming in from Pokemon can be one of these 9. See enemy, under attack, see item. Those are changes in the environment. Attacking, pursuing, high health, low health, almost dead, has weapon. These are state changes in the bot itself. So, external, internal. These events come in. They go to a class that I named the amygdala. And this is a simplification of the algorithm, so I'm actually combining a couple of classes. I know that's bad form. Trust me, the stuff is broken out better. But the amygdala, what does it do? Well, it takes the personality and the event that came in, and it emits a tuple, an array of an action with a strength for that action. So to give you an example, the personality comes in, and he has the extroversion of 0.7. And the event that came in was see enemy. And in this case, it emits an action of pursue. And again, we'll just use a scale of -1 to +1 of 0.9. So that's like a strong pursue action. Here are the possible actions that we can emit. There's 13: attack, upgrade weapon, change weapon, stop to think, dodge, crouch, uncrouch, look around, pursue, run away, medkit, seek item, collect items. So those are the things that we can actually affect in Unreal Tournament in our level of abstraction. So how does the amygdala translate the personality and the event that came in into this action with its strength? Well, if you have way too much time on your hands, you might build a Rails app in Zool that gives you an SVG interface with Bezier curves so that you can manipulate this line and create a function. But this actually was very useful. So the x scale 0 to 100, we can say that's our personality factor for just this one factor, just extroversion. And the event that we're looking at here is see enemy, and then the y becomes the strength of our output action, which was pursue. So basically we say, 0, the person's not extroverted at all. At 100, they're very extroverted, so they have a very strong pursue action emitted. Right? There's a problem with this approach. 5 times 9 times 13. 585, that's a lot of functions to create, to sit there and create. Fortunately, we don't have to create all of them because some factors just don't make sense, like imagination has nothing to do with seeing a medkit. So there are a lot of events, a lot of actions that we don't have to create functions for. We just return null. Yeah, but still what's powerful about the Big 5 framework in this case is that as a non-expert, I am not a behavioral psychologist at all, I can still sit down and make that function. And as long as the function from the input to the output is consistent for me and my interpretation of the Big 5 factors, then the behavior of the bot tends to be consistent, or at least seem feasible. And that would be true if somebody else had a completely different interpretation of the Big 5. As long as they were consistent in how they created those functions, the behavior of the bot should be consistent. So those actions come out of the amygdala, and we just put them on a stack. We end up with 585 possible potential actions with values. And we sum their values so that there's only 13 possible actions. And then we have to remediate that somehow. So the frontal lobe class looks at that, does a couple things. Again, I'm combining things into the frontal lobe that are actually broken out. But it looks at these actions and their strengths based on the event that came in. And it also looks at a decayed state of the previous actions and their values. So we don't want these, if somebody had a strong impulse to run one event ago, 1 sub-second ago, we don't want that to disappear and start over. We want some of that to carry over, hence the decayed state. So it considers those, combines them, picks the top actions, weeds out actions that can't happen simultaneously, you can't pursue and flee at the same time, and then finally sends the action back to the bot. Any questions about the algorithm so far? I'm glad that made complete sense to all of you. Okay, so the results. Well, I showed you the video. I can show you the video again. I could probably just show you video games for 40, the rest of the time, but I won't do that. But the results, well, I got 4th place. My algorithm isn't used in this way anywhere else as far as our research shows, which is cool. That's a reason to do it, if nothing else, right? We are all individuals. Another cool thing to fall out of this is that creating a new bot, I can just clone an old bot and go through the personality, and here I have like a small random fluctuation on those numbers, and I have a completely new bot. If you have a neural network, a typical neural network or evolved rule set, you can't do that. I mean, I'm just changing 5 floating point numbers. It doesn't get any easier than that. So it still has to be validated somehow, right? And ultimately, we want a validation that correlates to human behavior. One way to do that would be to set up a computer lab, a LAN party. I don't play video games, by the way, so set up a LAN party and have everyone who's going to play, we have tests that we can get their personality profile ahead of time. And then we can quantify their behavior, like the times they attack and flee, how much time they spend exploring, stuff like that. And then we can create bots that have exactly the same numbers for their personality profiles, quantify their behavior, and compare, and see if our bot is, in fact, quantifiably similar to humans with the same personality profile. That's pretty cool, and I don't know of any other algorithm that has a scenario that lends itself to this. Another cool thing that we can do with this kind of setup is, right now a lot of video games, I'm told, when you're playing them, they will actually try to figure out, they don't necessarily use the big 5, but they'll try to figure out things about your personality, and then they'll change gameplay based on what they think would make a more enjoyable experience for you to play. Well, we can do the same thing, but do it one better. So say like you want to go into a room and, like, I don't know, you don't have time to make friends, or I mean, you have a lot of friends, but you don't have time to make new friends, and you're in different time zones, so they won't play with you for whatever reason. But you can just fire up bots that have like similar personalities to them. And if their behavior is indistinguishable from a human, if we're passing the Turing test, then what's the difference? Right, so talking to each other afterwards. But that's a different test. That's another algorithm. We won't. Besides, who talks to humans anymore? Stochastic testing. I want to say something about stochastic testing, because So stochastic means there's a random element in there. And we actually, like the random number generators in Ruby itself, right? We have test flows. We can say if it has an exponential distribution, we can use a chi-square test or one of the others to make sure that it generates numbers in the right distribution. So we kind of know how to test stochastic processes. The algorithm I described isn't actually stochastic. I don't throw any random numbers in there, but we have that first requirement of it being unpredictable. So it's kind of like it is random or pseudo-random. I'm not really sure how to resolve this yet. We don't have an integration framework to test this. I'm actually so bad at playing that when I go into the game, I'll tweak something, I'll go into to see if the bot is behaving the way I expect it to. He kills me before I can see any behavior. So it's very difficult for me to test this. And it's difficult for me to outline how to test something that's inherently unpredictable. Feasible is maybe a little bit easier because we can enumerate things that aren't feasible, right? Like if the bot is just jumping against a cliff, then that's not feasible really for human behavior. But those are too numerous to actually, there's too many to enumerate. So we can't sit there and write a test against all of those. So something this level of complexity, I'm really not sure how to solve that. But I think it does have to be a solved problem for this emerging field of computer science or computology to handle somehow. Of course, the ultimate validation is to win the 2K bot prize. This was actually surprisingly easy to get started in as a project. So if you have any interest in playing, it's a heck of a lot of fun. The ultimate prize, I think it's $7,000 or something this year. So it has a prize. A lot of bragging rights. A lot of people have been working for years on their entries, and some companies have sprouted out up just around these. Teams of up to 4 people. I work by myself, but so a lot of people put a lot of work into this and other game competitions like it. But yeah, so I encourage you to look into it if this is your thing. But at the very least, let's be cognizant that we are kind of on the steps of a burgeoning field. And that's a lot of very cool responsibility for us as Ruby developers. So for that, I thank all of you for being my peers. And that's my presentation. I've got like 5 minutes for questions. Questions? So the question, it was, there are about 585 mapping functions. Some of them, like I said, are null, so we don't have to do that. Did I tweak them all by hand, or did I find an automated way to generate them? Man, I wish you had asked me that before I had sat there and tweaked them all by hand. No, I couldn't think of a way to. For me, it really required that behavioral psychology aspect of I mean, the power of the Big Five model is that those factors we can understand in layman's terms, like extroversion. Okay, I get what that means. So it's easy for me to say, like, the bot is in this situation, something happens. Well, does it have to do with people? If so, he's going to go towards more people. But I don't know how to do that programmatically. And there are other software libraries that use the Big Five. For example, there's a Java library that uses the Big Five to adjust mood, which is like this thing that has momentum, which then you can change to emit actions, I guess. And that doesn't work because I think they're confusing personality factors with emotions. Emotions would affect mood. I also don't know that mood can't change suddenly. So those were incomplete models for me. So no, there was nothing I could borrow from that I could find that would help me create the functions automatically. So I did have to sit down and tweak them, and I still tweak them too. And hopefully, when I can run that lab and get those results, I would tweak those functions to try to get a better correlation between my 5 factors and the measured ones and the expected behavior. Yep. Okay, so the question was, what function do I use to decay the previous state in order to combine it with the current state? Is that right? More or less? Yeah. Okay, so I actually don't recall which function is currently being used, but it's a very quick exponential decay. I wanted a hint of that past behavior to carry forward. What's really interesting, I use the same engine in a sales simulation, and it's actually more successful there because it's easier to see behavior in a strategic game than in an action game, when you're talking about personality profiles anyway. And in that case, what's really interesting is I'm pretty sure, I haven't tried this, but I'm pretty sure that in the sales simulation, if I made some of the actions that the virtual sales reps made, if I made some of those actions random, I think people would still go with it. Because it's unpredictable, and again, as long as it's not like outrageous, like they don't show up at work or something, it would. I think people bring their own personal framework to what the computer simulation is doing, and so they imbue it with their own story. So we really only have to provide a framework, unpredictable but feasible framework, and people create the story around it. But yeah, offhand, I don't know how quickly that function decays. Okay, so the two questions. The first one was, can I say anything about what personality profile makes a good Unreal Tournament player? Let me answer that first. I have no idea. There's another competition to make the best playing Unreal Tournament bot. It's completely different. It's a separate competition. Usually they run at the same conferences, so it's a lot of fun to watch. But and by the way, if you think you're a good player, you don't stand a chance against an automated bot, because as soon as you show up on the screen, you're dead. And so if I were in that line of research, maybe I would know more about playing well, but I don't want these guys to play too well. So I haven't looked at that question. It's an interesting question, but I haven't looked at it. It's kind of a different line of research. And the second question was, did I create a Ruby wrapper? No, not really. I just kind of wrote Ruby classes, unit tested them separately, then compiled them to Java classes and included them and called them from inside. So it's actually running from inside Pogamot. So it's running from inside Java. Okay, so if I'm understanding the question right, I like your example. So there's going to be some ratios of certain numbers to each other more than others. So did I consider that some personality profiles are going to be more likely and hence more real? I believe the way the personality profile, the big five is structured, is that they have like a median value for like average extroversion, average imagination. So in standardized tests, they'd have like, IQ is always centered to 100. Again, I don't have to do that because as long as it's consistent for me and how I interpret those factors, 0 is my average. So those are always going to be the most likely behaviors. So at the extremes, I wouldn't really have any. Yeah, it would be unlikely. But yeah, that would be interesting. And then maybe I could cut out more of those functions, right? Or limit them or something. Yeah. Other questions? So the question is, there's an implicit assumption that I make that how their personality profile influences how they play the game, has a correlation to how they act in the real world. As far as I know, I don't know of any research that has checked that. However, I still think since my bots never have to go out in the real world, I still think as long as they're internally consistent, well, as far as you guys know, they never go out in the real world. So, yeah, as long as they're internally consistent, it should be okay. Okay, thank you guys very much.
Do you have any testing where you change your behavior based on your work?
Yeah, I think we're over 40 minutes, so I'll talk to you later. Yeah, thanks guys.